Hello and welcome to our lecture on simple Django models. Now, as you've seen in previous lectures, we talked about SQL, structured query language, and that's how we talk to databases, and it's beautiful because it allows portability up to a point across databases. And we talked about all the create table stuff, and so this is just a bit of review where we can type these commands to SQLite. We run SQLite, we run a create table statement, and we do it to say .tables, so we can ask kind of schema users. We did all this in a previous lecture, and so that's basically how SQL works. And here's a series of SQL commands from a previous lecture, just kind of as review. It's pretty simple, CRUD. Now, one of the problems is as I mentioned, is that different databases like Postgres and MySQL do all this stuff identical, but then some more subtle things like how foreign keys work, which we'll learn in a bit, or how they do limits, like pulling like 25, next 25, next 25. That's a little bit different. And so if you want to build an application that talks across more than one database, you got to think a little bit. And one solution to this, also to kind of limit the fancy SQL you have to learn, I like to say that you can learn the first 60% of SQL in about 3 hours, and the last 40% is literally a lifetime. And so advanced SQL is difficult to do. It's really hard to teach a class in advanced SQL. I can teach you advanced features, but then there are so many features that you just can't learn in a class because which database you're using, and they're different for every database. So one thing that's happened in the past decade or so is the emergence of what's called object relational mappers. And that is you have the physical database layer, and then you have SQL, which is an abstraction. It's an imperfect abstraction. And then Django builds another abstraction on top of that called object relational mappers. So we just create a Python object and we ask that to be placed in the table. Now the object may have a name and an email address and a birthday or something in it. It can have all kinds of data in that object, and then that maps into a name and an email address, and we have to tell it, like, do we want this to be indexed and all these other kinds of things. We communicate through the ORM, so we leave the ORM alone. Now in Django, as we get more advanced, you can also sort of bypass the ORM because the way the objects are mapped into the tables is predictable. The names of the columns is predictable, and so it's kind of like it's a shortcut for. I like to think it's like the 80% of the most common things you do with a database are easily done with an object relational model, but object ORM. But ultimately, once you get to the more advanced things, you tend to not be able to do that with an ORM. You get to the point where writing the SQL is easier than using the ORM. But for about 80%, writing ORM code is way easier than writing the SQL. The other thing that ORM does is it allows you to have multiple databases, because the ORM code inside of Django knows the difference between SQLite, Postgres, and MySQL. And so you could actually start an application that uses SQLite during all your development, and then when you deploy it to production, you just go like, you know what, let's just use MySQL or Postgres instead. And that's quite cool. I find them limiting, and so I want you to know both how to use objects and how to use SQL, but understand that most of what you're going to do is to use the object relational mapping, and we get a lot of power with this. So if we look at sort of the way we communicate to the database, or the way we define the database, in SQL we create a table, and that right there is portable, but once you start doing things like adding auto increment columns and things like that, it stops being portable. And so that's the way we do it. But in Django, the way we do this is we have a file called models.py, and it's in the application folder. And then we are going to use object orientation. So we're going to, from Django.db, that's a package, we're going to import models. And models is now a class. And we're going to create a class called user. This is going to be equivalent to the name of the table. And we're going to, in the definition, we're going to extend models.model. And so there's a lot of, this is called extending, it's called inheritance. We're going to get a lot of features and functionality, excuse me. We're going to get a lot of features and functionality from this code. So there's probably 20,000 lines of fancy code that we didn't write that we're using. By extending models.model, we're getting all that. And then within here, we create a couple of attributes that basically says, give me a character field. Models is a class. Char field is a method within that class. Max length equals 128, and that gives us the name. These two things are equivalent. And what happens is when we build this and we do what's called run a migration, then Django will make this table for us. But then we have this abstraction that we can use to talk to it. So this is called a migration, and so you have to be in the projects folder. And so once you create a migration inside of your Django application, then you go up into the Django project and you say Python 3 manage.py. Now manage.py is kind of like the thing that starts everything. So make migrations is actually creating files, because the idea with migrations is that you would debug your migrations like on your development environment, and then once you know, you would move them to production. So you'd make the migrations in development environment, you'd get them right, and then you'd like check them into GitHub perhaps. And then in production, you would pull your migrations out of GitHub, and then the migrate. So the make migrations bit, that is creating a set of migration scripts. And you can see that it's making these files, and they're actual files, and you can go find those files like 001 initial py. And then the migrate is reading the migrations and then actually changing the database. So that's the one where you might be able to make a migration, and it doesn't matter what database you're going to use. Could be your development in SQLite and production in MySQL. You would do migrate in both of those, and in your development it would make an SQLite database, and in your production it would make a MySQL database and put the tables in. And the SQL might even be quite subtle, and it will be subtly different between them, but you don't care. So migrate is the act of creating the database. Now in our development environments, we're going to be creating a file called db.sqlite3. And so if you get all messed up, you don't have to remake your migrations. They're just sitting there kind of as part of your source code. And you can like get rid of the db.sqlite3 file and then run the migrations again if you get kind of messed up. So the make migrations reads this and creates these other little files. You can take a look at them. They're kind of like Django's internal files. They're Python. It's just you're not going to write them by yourself. But then the migrate reads the 001 initial.py and then actually creates SQL commands and runs those SQL commands for us. And so if we jump after we've done this, we see this file db.sqlite3, and we can jump in and take a look. Again, you have to be in the right folder, so you'd be in the Django_projects and then the folder of the project, but there'd be a file called db.sqlite3, go into a Linux command line, type sqlite3, db.sqlite3, and you will find a whole bunch of things. And when you go into SQLite and you type .tables, you will see that Django has a bunch of migrations that are all there from the sessions and stuff we're going to learn how to use later, authorization, etc., etc. But then the particular data model that you created, which is a user data model, there's a table in there for that. And if we use the schema command of SQLite3 and we say, hey, what is in that user model underscore user table? And you see a create statement, right? And so this is the actual create statement that the Django sent to SQLite to create the table. And I was talking about some of these things are quite predictable. The name of the column is quite predictable, ID, name, email, etc. It adds the ID field for you automatically. And most of it's portable, like this part here is quite portable, but this ID statement here, primary key auto increment, turns out that if you're in MySQL or Oracle or Postgres or SQLite, that's a little different, but literally the migrate takes care of all that because the migrate knows that thing, and as MySQL changes, that particular syntax doesn't change very much, but as MySQL changes, then the Django stuff changes and it all kind of works out. And so you can sort of run these commands and then sneak back into the database and you can see what they've done, but it's all very predictable. Don't want to spill my coffee on my computer. So You can also talk, you're talking at the low level when you run the SQLite command, but you can also be in that folder, same folder that has db.sqlite and manage.py. And then you can start what's called the shell. So this is different than the Linux shell, and you see the prompt change from $sign to three chevrons. And it's not the same as the Python shell, although it is the same as the Python shell with a whole bunch of Django libraries that are pre-mounted, okay? And so if you just say Python 3, you'll get this, but this next command that is from user model models import user, that will fail unless you let manage.py start your shell, because again it loads a bunch of objects and classes into your space, and then all of a sudden user model.models works, users there, etc. Okay, so this is pulling from your models.py file that you built, and so user model is the application name, and models is the models.py file. We import the user model, which is in this case a class. User is a class, and we're going to do a constructor call. And so we're going to say, let's make a new user, set the name to Kristen and the email to that email. And this actually has not done anything in the database. This creates, in effect, just a Python variable. And then to force it to be written to the database, we call u.save. And so save is a method on this new user object. Capital user is a class. We're using a constructor to construct from the class an actual instance, an object, and then we get that into u, the instance object, and then that object sits in our memory until we say save, and then it also pushes it back to the database. Now, one of the things that the save does, it assigns, in effect, a serial number or a row ID. If you look at these, they start pretty predictably at 1, 2, 3, 4, 5. But if you're getting a bunch of things coming in from a bunch of places, then the database just assigns each object, each row, and that's part of that whole auto increment thing. Come on, go back up. This whole auto increment thing that says, hey database, I'm going to put records in, I'm going to give you the name and the email, and you come up with a number, but then when you're done, I want you to tell me what the number is. And this is how you get that number, by saying, oh, print u.id. Now if you printed u.id before you did the save, it wouldn't exist. And then print u.email, you can see this email is just the data we put in, but now this is not only in your u variable, but it's also in the database as well. Okay? Now, we can dig a little bit into how this object relational mapping is working. And so if you're in the middle, you're doing things like that last statement, you can from Django DB import connection and then ask connection.queries. And then what it does is it just shows you a little bit of debug data and what it did, how it started, the fact that it ran an insert statement. And again, this looks kind of familiar. This is it's making up SQL for you for that insert, the save statement, right? That save statement there. It's making that insert for you, and then you can actually see what it's doing, right? And so this save, set up a thing and save it. You don't need to know insert into or whatever, because the object relational model does it for you, right? And this is kind of what we did before, insert into capital users by hand. And so again, you'll find this ORM is going to save you a whole bunch of time for 80% of the things that you do with the database. And so you can do basic CRUD operations with this object relational mapper. The save is the insert. You can select is basically user object values. That's like select star, so give me all of the objects. A where clause is user objects filter, and there's your where clause. This is email's a column name, and c7@umich.edu is a value in that column. Values is actually go get them, so you can create kind of a query. So if you don't put values on, you get sort of a query that's not yet executed, and then values says go do it now. So you can do a different, you can delete something where you say, and so this is a little different syntax. This is kind of a selector that says these are the variables to select, and dot delete says, the rows to select, and then delete those rows. So value says retrieve the rows, delete says get rid of the rows. And then you can, again, the same kind of thing. This is kind of like a where clause. User objects filter email equals c7@umich.edu dot update, and then change this column in a way. and you can, go retrieve all the values. And there are things that correspond to lots of the SQL, like give me all these values, order by email, etc., etc., etc. So it's kind of a one-to-one mapping, and you will, again, you're going to do a lot of programming using this ORM in Django, and every once in a while you'll sneak down to SQL. And that's why I sort of teach you the SQL first. And there's lots and lots of fields that might not actually be represented exactly the same way in the database. So for example, an email field. Databases commonly don't have email fields. There might be some databases that have emails and others that don't. But because the object relational mapper is a layer between you and the database, and you say, I'd like this to be an email field, then it can add rules and stuff like validity checking, etc., to say, you know what, that doesn't look like an email address. And so there's all of these things, and these are very useful. And later we'll talk about connecting tables, and we'll use things like foreign keys and many-to-many fields and one-to-one fields, and those are less about the data and more about the connections between tables, which we'll talk in coming up soon. And so just to give you a sort of a bit of a sense of where you're at, this is our application, right? And so we have a browser on the left-hand side with a user doing some clicking. By now you may have created a urls.py file, and that takes the syntax of the GET request slash this, slash that, slash whatever, and routes it to a particular view coming from the views.py file. You may or may not have made one of those. Templates and forms help produce output. But the models are our interaction between us and the database. And so the actual code we write in Django can talk through the models to the database, which you may not have done yet, but this shell is talking through the Django models to the database as well. And if you're starting to use the admin user interface, the admin user interface talks to the database through the models, and it's informed by the kind of things that you add to admin.py. If you want to use the Django admin interface and have your model shown a particular way, it's got a bunch of defaults, but often you want to override those defaults, and so that's what you put in. And the model.py file informs this connection between the database, and it also sort of informs the kind of code you write here in a view code in Python or in the Python shell. That's kind of the Django shell, which is a Python shell with all that stuff added to it. Okay, so this model.py is critical to defining our relationship between all of our Python code and the admin user interface and the actual database. And so you'll see a recorded demo where I go through a bunch of those things, which I kind of...
Hello and welcome to another walkthrough for Django for Everybody. Right now we're thinking about data models, and I'm going to show you how you can walk through and run this particular little example in the Django shell. So let's go ahead. We're going to Python Anywhere. I've already got a bash console. I love the idea of this bash console. This is Linux. I think that everybody should be learning Linux. So if I start my home directory, cd ... means go up a folder, ls -l. I got some folders here. I got DJ Free Samples, which I try to convince you to check out so that you can edit your file, edit my files, look at my files, use that as sample code for your own work. There is instructions on how to clone that, and so, but we're gonna assume it's already there, and follow the instructions. So we're going to go into that folder cd, and then we're going to type a git pull. And the way this works is this is in GitHub, and that way if I've made any changes or fixed any bugs in my sample code, you've always got the latest code. And I've already done this, but there is a bunch of, so, oh, by the way, I got to switch into my Django 3. I got to switch into my virtual environment. You'll notice I didn't have virtual environment, now I do. And that's because this next command is pip command. Not Django 3. This pip command is going to change the Python configuration, and it's literally best if you do this in a virtual environment, so you're not like messing up your overall Python install on your system, whether it's your desktop or Python Anywhere. with my particular requirements. This is installing a bunch of utility code, etc., etc., etc. And is there some new? It looks like I got some new version here. And most of it's already there from a previous time that I installed all this stuff, but it's good that I ran this to make sure that I have all of the Python requirements needed for this. So now it's done and it's installed all of my requirements. I'm going to type the clear command to kind of clear up my screen. Okay, so there we go. So then the next thing you run is this command that we run. We're going to run a lot, especially in Python anywhere, is this python3 manage.py check. And what this does is it reads through the urls.py and the applications and a whole bunch of other things, and it blows up. And so if you get no issues, that's good. The point is you do not want to continue down this other path unless check passes, because make migrations starts to make changes. So make migrations is Django reading through all of the models.py files and creating migrations. Now migrations are not SQL, they're actually Python code, and because this was checked out from GitHub, all of the migrations are actually sitting there, right? There's a way if you want to remove the migrations and remake them from scratch. So the migrations reads models.py files like vi users models.py and reads these and then creates migrations. And then the next thing that happens is we're going to actually, I'm going to get rid of my database.sqlite3. You can, that throws away your database. It actually tells you to do that right here. And then migrate reads the migrations. Migrate doesn't read the models.py files, it reads the migrations. And then it creates the database. And so it's going to create a database, and it is going to create a bunch of tables in that database. And so you see for each of the applications that I have in this Django project, it's creating a bunch of tables. And so here, for example, is users one initial. That is the table that I'm going to mess with up to that point. So now I've done all this stuff, and it's time to actually run Python manage py shell. So what this is it's like starting Django and loading all the Django libraries and reading all the Django configuration files. So there could be a bunch of errors that happen at this point. And if they are, go back and fix those errors, okay? You can't just like, oh, I think I'll ignore those. This is what the manage py check did. It sort of did that. But now it's like you're in a views.py file, which we'll see in a bit. You can type Python commands that Django, inside Django. It's not just Python, but Python with Django and all of your Django application preloaded. So that's why it takes a bit of time to get to this point. And now it's pretty easy. So now we're going to type Python, right? And we're going to import the user model, and that worked. And now we are going to create a new user object. So these next two commands are really important. So what that user says, name equals Kristen, email equals, that is going to create a new user model object in Django's Python's memory and give it back to me in the variable u. At this point, it's not stored in the database. So if I say, where did this store in the database? Oops, u.id. There is no ID currently, because if it was given an ID in the row, it gets a serial number basically of the user after it gets saved. And u.save says, see this u variable that I've got in memory full of data? Well, store it in the database. And now I can say u.id, and I can see that it was stored in the database at position 1, which is exactly what you would expect. These numbers are pretty simple. They start at 1 and they go up, and we'll see as we do a few more folks. Let's put a few more folks in. We'll reuse the variable u. I'm just going to copy and paste all these at the same time. And now I can say u.id for who we're set. u.name is Sally. That's the last one I did. And then u.id is 5. It's the 5th one. So now I have 5 models that have been persisted, stored in my database. Now if I want to retrieve those, user objects. So user is the name of a model. That's actually a class. Objects is a attribute in there which has a method of values. So I can get back all the values, and you see what I get is what's called a query set, but in all intents and purposes it functions like a list, and then in that list there is a series of objects, and it looks exactly like the data that I put in, but it pulled that from the database. And the thing that's in there now is the ID is now in there. So this data has a primary key for every one of the rows that I put in there. And so I can say that. So I can add a filter. And so you'll see this pattern where user objects, and then I sort of throw these things in, and then the dot values comes at the end. And that's because filter is a method that returns a thing that has a method. So this is the values method that the filter returns. And you can just keep putting these together. So I can say this is like a where clause in SQL. So this basically says give me only, and it's a query set, so it's a list, but there's only one object. Now, there could have been more than one because we don't have any uniqueness constraints on email. There could be more than one record that matched email c7@umich.edu. You can delete, so this is basically, let's go grab that record, but then run the delete method on that model object, model instance. So this will get rid of the TED record. We can go retrieve all of the objects, and we can see, oh, there they are, but there's no TED. There was a TED before, and now there is no TED. We can update. So let's check this one again. Let's grab that and pull out. So we're going to change this name here. This is in the database, and so we're doing CRUD here. And so we're going to update, create, read, update, and delete. And update's the last one we got to do. We deleted. And so again, we're going to grab all the objects. We're going to filter them down with a where clause to the ones where email c7@umich.edu. And then we're going to set new values. And so if I now say, what is this? Well, the name has become Charles. So it switched from Chuck to Charles. And it's in the database, right? This is not just in memory. This is Django writing all this stuff to the database. Now, just a little bit more, and you can go read up on this, and we'll have lecture after lecture and all kinds of example codes, but you can sort of sort this stuff by email ascending. So A, C, Colleen, CVL, and then K comes later, or we can descend. We can see them descending. So did I get that wrong? Oh, that's in descending order by name. So S, K, C, CO, CH. So they're descending by name. So that gives you just some of the kinds of things that you can do in the Python shell. Let's say quit parenthesis here. Yeah, there we go. Okay, so I hope that you found this this Django for Everybody walkthrough useful. Cheers.